Hey there, my college algebra friends. Today we are going to be looking at 2.2a, solving linear equations. This will probably be quite a heavy review, but let's get to it. All right, first type of thing we're going to look at is how to equations with one variable. We alluded to this last time. A solution is a value for our variable that when we plug in makes the equation true. Okay, we kind of talked about that in 2.1, or we will in more detail. Just a good vocab to know. Now we're going to talk about linear equations, linear equations, and what's a linear equation? A linear equation, a linear equation, is one that makes a line. So it's going to be to the first power for your x. Okay, you have all x and y intercept, makes a straight line. All right. So how do you solve these? It's easy as 1, 2, 5, 6, 9. No. First thing you're going to do is simplify both sides of the equation. You're going to force the variable terms to one side, force the constants to the other, divide by coefficient. AK, simplify, get all your similar terms on other sides, and then solve. And then you can plug it in and check. That's the nice thing about solving this, is you can always plug in and check. You can graph them and check as well. That's actually, I don't know if I'm going to show you that today. So solve this equation. It's a first order linear equation. Pretty straightforward stuff. First thing I'm going to do is simplify both sides. On this one, nicely enough, there's nothing to simplify. We're good to go. There's no x's to combine, no distributive property, so I can just start. I'm going to move my constants over, add a 4 to both sides. 3x equals 21. Opposite of timesing by 3 is divide by 3. And x is 7. There we go. Hopefully that's a nice stroll down memory lane for you all. What if things get a little bit trickier though? Good question. What if we see one like this beast? Example 2. Well, the first thing I got to do is simplify both sides. So that's distribute, combine like terms. All right. So I'm going to distribute first. That's 5x minus 10 plus 10. That stays the same. Equals 3x plus 18. Okay. Now I'm going to combine my like terms. Need to get as simple as possible. Negative 10 plus 10 is my bank account. 0. Right side I'm doing nothing to. It's already simplified. Alright, now I got to get all my x's onto one side. So I'm going to subtract the 3x over. Make this upside down T chart. I get 2x equals 18. Those cancel, as they should. Divide both sides by 2. X equals 9. Ta-da! Alright. We are actually just trucking right along on this one. Alright, let's try another one. Or actually, yeah, let's try it. We'll do these two relatively quick. You guys can try some. Then we'll do the rational ones. Those ones are actually pretty tricky for being called rational. Alright. Solve following equations. First thing, look for any simplification that can occur. Nothing. No like terms combined, no distributed. So what I'm going to do is I'm going to move my y's over. Could I subtract the 9y? Yeah. Didn't want to. So I get 5y minus 7 equals 15. Add the 7 over. Draw an arrow because I misjudged. So 7's cancel, 5y equals 22. Divide by 5, and I get y equals 4.4. That's it. Now I can plug that back in to check and make sure. I have an answer key, so I'm pretty confident, but as always, when you guys are taking your test, plug that back in. So you take that 4.4 and plug it into both y's and see if it's true. Check if it is a solution. Okay. Let's do this one. Distribute the 2. 6z minus 2 minus 5z. I always put this little dash there so you know. Equals 32. Combine my like terms. 6z minus 5z is just good old-fashioned 1z. 1z like a baby wears. Ha. I'm sorry. Alright. Now, nothing else to simplify. I'm going to add 2 to both sides. Get z equals 34. Now again, I can plug that in and check. Alright, we're looking good. This is pretty quick. If you have questions, don't be afraid to ask. Alright, let's try this one. First thing I got to do is simplify. So I'm going to distribute the 2 and then combine like terms. The left side is going to stay the exact same. The right side becomes 2x minus 2 plus 3x plus 5. Alright, combine my like terms. You get 5x plus 3 equals 5x plus 3? What? Subtract my 5x over. They cancel. They both cancel. I get 3 equals 3. Zoink, Scoob. Where did the x go? Well, the x is gone. And this is true, right? So if you're left with a true statement, it means it doesn't matter what I plug in for x. It's always true. And if that's always true, it means that the answer is actually all real numbers. It works for any number you'd plug in. You can try 1, 2, 0, they'll all work. And you can check that too if you want. So that's the actual answer, is all real numbers. Alright, let's try this one. Nothing to simplify. Subtract my 2y over. I get negative 8 equals 6. Well, that's not true. That'll never be true, ever. That's not true. The actual answer is the null set, or no solution. No matter what you plug in, it will not work on this one. All right, let's try some more. All right, feel free to pause the video and try these. I'm going to give you the answers. So pause it, write these down, try them. The answers are negative 2/3 or negative 0.67 for that one. And the second one, the answer is, well, x equals. The second one is y equals 25. Again, pause, try them. If you have questions, don't be afraid to ask. Now, so far, you're probably pretty good at most of these. What if we get an equation that doesn't look linear? Is there a way to make it linear? Let me show you how. Let me show you how I do it. Now, I do this a different way than Dr. Webster does, so if you want to watch his video on a different way to do it, because you don't like mine, by all means, please do so. We're doing the same examples, okay? We'll get the same answers, I just do it a different way. So, right now I have x on the bottom. It does not look linear, so I need to make it linear. Well, I don't have to. All right, this one, never mind. We do it the same way. So what I'm going to do on this one is I'm trying to get x by itself. Okay? So I'm going to move this 8 over. I get 3 over x equals negative 6. Now I'm going to bring up something from a long time ago. I can make that negative 6 over 1. I can cross multiply, right? Cross multiply to get 6x equals 3 times 1, right? So that's negative 6x equals 3. Divide by negative 6. You get x equals negative a half. Or negative 0.5 if you're plugging this in Moodle, right? That takes decimals. Alright, so that's not so bad. If x is on the bottom, just cross multiply. Get it out of there. What about this beast? This one's a little bit different. With this one, no matter how I manipulate it, I'm not getting rid of the x on the bottom. So I need to embrace it. So back in the day, if you had something like this, you had to find a common denominator, right? Let me move this keyboard out of the way. So I'd multiply by like 3 over 3 and 2 over 2 to get something I can actually do. Same process holds true for these. So when I look at, if I look at 4x, 6, and 12x, is there a way I can multiply 4x to get to 12x? Yeah, I can multiply it by 3. Well, 6 to get to 12x, I can multiply by 2x. I'm just picking my largest number with a variable, right? Seeing how can I get there. So I can find common denominators. So I will multiply this by 3x over 3x. So my bottom becomes 12x. I'll multiply this one by 2x over 2x. So I get negative 3x over 12x plus 10x over 12x equals 17 over 12x. Again, Dr. Webster does this a different way, and you can watch his video to see how he does it. Now, once all the bottoms are the same, I can ignore them and just do that top equation. Negative 3x plus 10. Oop, that's just negative 3. I can't multiply that by x. I'm so sorry. Because that'd be x squared. My apologies. You guys see that? Because I had to multiply by 3 over 3. I had it here. I wrote it wrong over there. Alright. And that'll equal 17. Solve it. Add the 3. Add the 3. I get 10x equals 20. Divide by 10. Divide by 10, and I get x equals 2. Alright, I got one more for you. This one's going to take a little bit. Alright, we're going to do the same method as did. Find a common denominator. So think about your bottoms. I get x plus 2, 2, and 4 times x plus 2. Now what can I multiply x plus 2 by to get 4x plus 2? I can multiply by 4, right? And then they'd be the same. Now what can I multiply 2 by? Well, 2 times 2 is 4, and I'm missing the x plus 2. And that one's good. That's our most complex. I'm going to leave it. So when I do my common denominators, I'm going to times it by 4 over 4. And over here, I'm going to do times 2 times x plus 2, 2 times x plus 2. let's see what happens. Let's just try it out. So 4 times 5 is 20 over 4 times x plus 2 plus 3 times 2 is 6 over 2 times 2 is 4. And we didn't do anything to that equals part. Now, if all my bottoms are the same, I can just take my tops and do the equation. There we go. Now it looks just like the problems we did before, so I'm going to do it pretty quick. Sorry, I'm running out of room here. Distribute the 6 through. Combine like terms. Subtract over the 32. Six x equals 3. Divide by 6. And x equals a half. There we go. That's all there is to it, folks. Feel free to reach out and ask questions where needed. More than happy to oblige, and have a good day.